Hi, my name is Andres Aguiar. I'm a product manager at Okta. I joined as part of the Auth0 acquisition, and I've been in the company for 5 years. I'm based in Uruguay in South America, so that's where my accent comes from, in case you were wondering. Thank you for joining this session. We are here online to answer any questions that come up during the session, so please use the chat function. Today, I'm going to share some ideas about how you can prepare your products for the changes that we think are going to happen in the authorization space in the next few years, specifically around SaaS applications. As you probably know, we've seen a great acceleration on the adoption of cloud SaaS tools at organizations. 187 is the average number of applications that medium-sized companies use, up from 175 a year ago. As the number of applications employees need to access increases, it also increases the complexity for handling access management. If the chart looks complex, try to extrapolate it to 2,000 employees and 187 applications. It becomes quite hard to manage. Today, we'll get deeper into the authorization problems we have and how we can solve them. Let's start by defining the difference between authentication and authorization. Authentication is about verifying whether someone or something is who they say they are. Authorization is about verifying what someone or someone has access to. Logging into an application is an authentication process. Verifying if I can access a specific document is an authorization process. Implementing authorization is complex. It's complex for any kind of application, but because SaaS applications are critical for modern organizations to operate, the stakes with SaaS applications are higher. Let's review the authorization journey of a typical B2B SaaS app where the application is used by the employees of an organization. The very first authorization challenge we'll face for any app is implementing multi-tenancy. Picture Salesforce as an example. In this image, Salesforce would be the SaaS application, and the customers accessing it want to be sure that no other customer can see their content. Every SaaS founder at some moment had nightmares about an employee from one company seeing data from another company. Getting this wrong can be devastating from companies all sizes. In the initial version of the SaaS application, having a single administrator role can be enough. In Auth0, we had a single tenant admin role for around 5 years. At some point, the company will start trying to sell to bigger customers and they will demand more granular permissions. The employees that manage billing information are not the same employees that manage users. This is an important step in becoming enterprise ready. Give your customers the ability to define multiple roles to use in your application. A possible solution for the scenarios we just described is to combine role-based access with attribute-based access control. Using role-based access, you can define multiple roles, and each role would have different permissions. In this case, we have an admin role with a few permissions and a billing manager role with other permissions. In your application, you will check for those permissions, but also make sure that each employee is interacting with the content of its own company. In the code on the right, we check that the user has a proper permission and it belongs to the organization they are updating the billing details for. This is attribute-based access control. You use properties of the user and the entity you want to update to decide if the operation can be performed. The authorization logic can be written in application code, as in this example, or in an API gateway or API proxy. Continuing the journey of our SaaS application, at some moment, we would start getting requirements for implementing finer-grained access control. Instead of managing all users, you will want certain employees to manage the marketing group and other employees to manage the sales group. If you are building a document-based collaboration product, sharing with multiple users would be a core feature of the product you will need in version 1 instead of a request you get later. It's not a feature that is simple to build in products with a larger use base and millions of documents. For example, it took years, probably not 100, for Box to build this feature. Let's stop for a minute to understand how you can implement fine-grained access control. In general, there will be a record in some database stating that a specific user group has access to a specific resource or set of resources. This cannot be solved with role-based access alone. To authorize access, you need to read additional information, usually from a transactional database. In the example above, the database access is encapsulated in the isDocumentShare method, which will make a SQL query to check if the user can view the document. In some scenarios, these queries can be quite expensive to run. This adds additional load to operational databases, and latency to every API call that needs to be authorized. Another issue with the previous approach is that the authorization logic is embedded in the application code. This makes it difficult to understand how authorization is implemented. You need to read all the code of the application. Right? An alternative approach is to use policy-based access control. In that case, the authorization logic is defined in a language that is specific to the policy-based access control tool you use, and it's invoked from the application code. These policies can be managed independently of the application, which makes them easy to understand and to update. The code we previously had in the previous slide is now split in two. The part in the bottom runs in the application, the part in the top runs in the policy engine. The application code still needs to provide all the data to evaluate the policy, so the complexity of getting the right data is still part of the application code. Let's go back to our SaaS application. Now we are a few years in our journey, we have a lot of customers, annual revenue is growing, investors are happy, and now the product grew and it's built now by multiple teams, each owning a specific product domain, their own services and databases. Maybe we acquire another company that has products and we want to integrate them into our offering. Over time, the patterns to implement authorization evolve, and each team is using its own implementation. Some teams define a specific role for each service, other teams use roles that are shared across services. Acquired products would have their own authorization implementation. This can impact your user's experience that now need to define similar role for different components of your products. All of this can lead to an explosion of the ways to implement authorization. Additionally, each external request to the system needs to be authorized in each service, hitting operational databases multiple times, adding latency to the external code. At this moment, it's very difficult to understand how the system behaves from an authorization perspective. Of course, this is a good problem to have because it means your product succeeded, but it's a problem you will need to solve eventually. So now things get more interesting. So we are in a position to sell to those companies that have more than 2,000 employees and an average of 187 applications that we mentioned in the first slide. How do those companies manage access to all of those SaaS applications? Of course, using more SaaS applications. So we have products like identity governance, privileged access management, cloud infrastructure management. There are basically two pieces of this puzzle. On the left side, some of the applications let you provision employees with access to different apps and resources. In this example, we have an identity governance app that provided a Slack-based flow to request access to specific projects in a tool called Bureau. The example on the right is from an application that accesses all the permissions from multiple SaaS apps and gives a unified view of what a specific employee has access to. To become enterprise ready, our SaaS app needs to integrate with these tools. And to do that, we need to expose all the authorization related data to these third-party applications. That includes the different resources that organization owns, the different roles and permissions that users can have. Exposing this data is difficult because if you implemented authorization using RBAC, ABAC, or PBAC, you cannot use the same abstractions and artifacts to answer which users have access to this specific document, which are the resources that this company owns. You need to recreate and probably duplicate that logic to answer those questions in custom SQL queries. So here's a summary of the challenges that our SaaS application had to go through. Given the authorization logic is often embedded in application code, it's difficult to understand the system behavior from an authorization perspective. Different subsystems implement authorization differently, increasing the cognitive load for development teams and sometimes impacting the customer experience. Operational databases get additional load and increased latency that it impacts the system global latency. Also, integrating SaaS applications with security compliance tools requires significant investments and is usually done by a small percentage of SaaS vendors. Now, what if you need to build a security or compliance product? There's a wide spectrum of products in this space and a lot of acronyms to learn. What they have in common is that at a high level, they care about two things: granting access to specific employees or specific resources, like identity governance or privileged access management, or monitoring who has access to what. It can be in real time for security purposes, like cloud infrastructure entitlement management, or every quarter for compliance purposes, like identity governance products. If an identity governance vendor needs to implement this feature, a request approval flow, they will need to invoke very specific APIs to list all the projects for that organization that has in Vero, right? So if I'm customer A and I want to get access to a specific project, I need to call an API in Vero that lists all the projects that customer owns. And then we need to call a specific API to grant Marcy, in this case, permissions to access that project. Supporting this for hundreds of SaaS applications is practically impossible for any identity governance vendor because they need to do this specifically for each application, specific integration for each app. So they usually end up supporting the most popular applications. Now let's suppose you want to build a product that lets you audit what a specific employee can do across all SaaS applications your company uses. In this case, we want to know what Chloe can do. The product will need to ask each application for Chloe's permissions. You need to call application-specific APIs to do this. Given there are too many SaaS applications, you end up supporting the most popular SaaS applications. Of course, integrating with the most popular SaaS applications is better than nothing, but it doesn't solve the problem we have as an industry. Bad actors will always take advantage of the weakest link. If there's one application where sensitive permissions are not managed properly, that's enough for a bad actor to succeed. As an industry, we need all SaaS applications to be integrated in this ecosystem if we want to provide secure access to applications. How can we get most SaaS applications integrated with security compliance tools? To achieve that, we believe we need to simplify authorization for B2B SaaS scenarios, both for companies building SaaS applications and for companies building security and compliance tools. We believe that with the current state of the technology, we can solve this problem at the scale the industry needs. So what's next for authorization? We as an industry kind of solved authentication. Of course, there are still a lot of challenges, but the core building blocks are there, and there's been a lot of progress in the last 10 years. We created the right abstractions, we agreed on the standards to implement those abstractions, and the standards were widely adopted. But we haven't solved authorization yet. Role-based access, attribute-based access, policy-based access are all good abstractions that help us to get here, but they haven't solved this problem we are talking about. We think they are incomplete abstractions, and to solve the problem we have at the scale we need something else. And as an industry, we are trying to solve authorization. In the last few years, the number of companies and products working on building authorization products for developers has increased a lot. One approach several companies are trying is to use a different way to model authorization, which is called relationship-based access control. A few years ago, a group of engineers from Google published a paper describing how they implemented authorization for all Google applications. It's based on relationship-based access control. Google Zanzibar inspired a few implementations over the years. Airbnb and Carta blogged about how they did it. And at Okta, we also decided to implement a SaaS version and an open source version of it. The open source version, OpenFGA, is now owned by the Cloud Native Computing Foundation. Explaining how Zanzibar works will take a full presentation, but I'll try to explain it at a very high level. You first define what's called an authorization model, which defines the relationship between the different entities in your system. In this example, we are modeling a simple document management system with user groups, folders, and documents. In this case, we are saying that a group has members, which are users, that a folder has an owner, which is a user, that a document has a parent, which is a folder, and that to read a document, you need to be the owner of the document, a viewer that is explicitly assigned to the document, or the owner of the parent folder. So we are defining an authorization policy by defining the relationships between the different attributes of the different entities that are used in our application. Note that the model is very specific to our app, right? So we have a model for a document-based application. In addition to the model, you need to provide data in terms of the relationships tuples, which are in the form of a subject has a relationship with an object. We define that Matthew is a member of the sales group, that Sally is a viewer on the pricing document, and that the sales doc folder is the parent of the pricing doc. Then we can ask the authorization system a simple question. Can a user perform an action on a resource? In this case, Matthew can read the pricing document because he's part of the sales group. Peter cannot because he's not part of the sales group, he's part of the marketing group. And Sally can read it because she was assigned directly as a viewer of that document. With this approach, we have all the data we need to make authorization decisions in a single place, a permission database. We can use it to perform fast and scalable access controls without hitting our operational databases. This is what makes it excel over attribute-based access control. You don't need to hit your operational databases or get that data, know how to get that data, because all the required data is already in this Zanzibar store. This is when things become interesting. Once we have this data, we can potentially ask other questions to the Zanzibar store, like returning all projects in an organization, everything that a user can access, who can access specific resource. With the same model and the same abstractions, we can implement access control and also enabling querying authorization data. This is what relationship-based access control enables. This approach is flexible enough to let us define multi-tenancy, additional roles, fine-grained permissions, and in the same way that Google is using Zanzibar for all of their applications, including several chat applications, the system is flexible enough to accommodate the needs of multiple services and products. And given the Zanzibar store has all the data required for making authorization decisions, it's much simpler to create APIs on top of it and expose that data to third-party security and compliance applications. From the point of view of a B2B SaaS vendor, it looks like a very good solution for a generic authorization system. If we look at it from the perspective of the security or compliance vendor, if they can easily access the information that is in the Zanzibar store with a standard API, it would be very easy to support additional SaaS applications. The same API can be used to integrate with every SaaS application. Following this approach, we have many more SaaS applications integrated in the security compliant ecosystem, and companies will operate in a much more secure environment. We think this approach is quite promising, and it can be the foundation of how we solve authorization over the next decade. We think modeling authorization as data can help B2B SaaS applications to build more flexible, scalable, and auditable authorization systems. It can greatly help enabling applications to become enterprise ready and integrating them with the rest of the ecosystem. We think that creating standards on how to expose authorization data like resources, role, groups, permission will also be critical to simplify how the security compliance ecosystem can integrate with more applications. Sadly to know if these standards will be created, but hopefully they are, and we'll get involved when the time comes. If you are in a leadership position on a B2B SaaS company, you should start thinking about this now. In the same way you had to re-architect how you implemented authentication in the last few years, it is very likely that you will need to do the same with authorization in the following years. Once that's done, we'll be much closer to a world where everyone can use safely any technology. And I think it will be an interesting ride. I hope we can see each other again at the end of the decade and celebrate that we solve authorization together. Thank you very much. I'll be around to answer any questions, so feel free to type them on the chat window now. Thanks.